Bob's Hot Dog Stand. Bob wants to open a hot dog stand in the greatest city in the world, Silver Spring, Maryland. He does a survey of Washington area hot dog stands and gathers the data in Exhibit 1, which is what we see before us. He knows he wants to price his hot dog in the same range as everyone else, neither higher nor lower than the pack, but he isn't sure what would be the exact right price for his hot dog. Okay, first off, when we look at this data, we want to know what the range is for the other hot dog stands. Now we can eyeball it and go through the list, or we can use the max and min equation. So min tells us that the lowest price in this column is 1, and if we say max instead, we see that the high is $2.50. That's my little shortcut. Now, as far as the regression is concerned, part of the reason why Bob wants to know what other people are charging is because he wants to know how price affects quantity. Now, there's other things that affect quantity, assuredly. How clean and how large your hot dog stand probably helps attract people. And your location. Good neighborhoods, places with lots of foot traffic probably sell a lot more hot dogs than places that don't. But let's do a down and dirty regression, see what kind of R squared we get, and just improve it if that ends up not being good enough. So I'm going to go to Data. Oops, not Solver. Data Analysis, Regression. And as you can see, I've set it up so that my output is my sales quantity, and my input, my X range is my price. And I checked labels because I included the top row. So here for my first regression, you can see that my R squared is 80%, which is sufficient. It's higher than 70. And my p-values are both extraordinarily low. So this is an equation that I can work with. And because we said that sales quantity was our Y, what our equation will look like is sales quantity equals negative 88.94 price plus 294.87 is my equation. Now another way to put that would be, you could also have it listed as 294.87 minus 88.94 price. Either way, it's the same equation. So now I can go to my model. And my sales quantity is an equation, 294.87 minus 88.94 times the price of my hot dog, which is here. And hot dog is the one decision in this model. Now, as far as the data from the case, it talked about the fact that his hot dog is a ballpark frank, which comes from a pack of 10. His bun is a ballpark bun that comes from a pack of 8. That he puts condiments on it, and that he serves pretty much every hot dog that is sold. There's also a bag of chips that is sold and a canned soda that is sold. So let's work this out. Our pack of franks and our number of franks, when you divide those, you get the unit cost of one hot dog, which is the cost of the pack divided by the number of franks that are in the pack. And the same thing for the bun. The unit cost of the bun is equal to the cost of the pack of buns divided by the number of buns in the pack. Okay? There's our condiments, which were stated explicitly in the case. A cost of a pack of chips. A unit cost of chips is equal to the cost of a pack of chips divided by the number of bags in the pack. And the same thing for sodas. The cost of the pack divided by the number of cans in the pack gives us the unit cost of one can. And finally, we see that he charges 50 cents for the bag of chips and $1 for the soda. So now that we have our equation for quantity, we can figure out what our revenue is. And our revenue is the price of the hot dog plus the price of the chips and the price of the sodas times the quantity. Our cost of goods sold is the unit cost of the hot dog plus the unit cost of the bun plus the condiments plus the unit cost of a bag of chips plus the unit costs of a soda. This is really important here, times the sales quantity, which is where a lot of people had problems with this one. And then finally, our gross margin, it's kind of our stand-in for profit because we don't know anything else about this model. Our gross margin is equal to our revenue minus our cost of goods sold. Now, to optimize our model, what we can say is we can go to Data, Solver, and we can say that our objective is our gross margin. What we're changing is the price of a hot dog, and we're saying subject to the constraints that each hot dog is at least $1 and no more than $2.50, which is what we got when we did the max and the min on the data. And then when we run Solver, we can see that the optimal case is $1.66, which gives us a gross margin of $242 for Bob.